Good afternoon to everyone present at this conference. For us, it is a pleasure to participate in this section. I am going to speak about development of an automatic control system employing CDIO standards and competence-based learning. I am a member of Electrical and Electronic Engineering faculty from the Universidad Pontificia Bolivariana, located in Medellín, Colombia. This presentation aims to focus you in the higher education area because this work shows the experience and result achieved by a controlled environment chamber development team, mainly professionals and students of the university. All this work was analyzed from the perspective of CDIO initiative, concept, design, implement, operate, and obviously in the competency-based learning. The automation project was carried out within the framework of a degree project from the Universidad Pontificia Bolivariana. So, in this slide, you can see the outlines of our speech from the framework of our development to the analysis of developed competences and some conclusions, beginning with the frameworks and motivating questions, later studying the different stages of CDIO, and finally building analysis results. Okay, it's very important to speak now about the framework of this project. So, the CDIO initiative is defined as an innovative framework which is expected to educate generations of engineers in the context of conceiving, designing, implementing, and operating systems and products for the real world. There are many connections between the proposed skills in different electronic engineering program courses and the consolidation through solving problems. The elements of CDIO initiative were identified in different development stages to find solution of an engineering problem. The automation project TOCO can demonstrate the importance of each stage in development of CDIO system. Which are our motivating questions? The main objective of engineering school is that the student abilities are strengthened through the development of competences that will enable them to a real, current, and modern labor market. Given the large number of proposed methodologies currently used in engineering schools, it is possible to consider the following questions. How CDIO initiative helps students to focus its work and learning? How significant is for the student for the development of competence the project-based learning approach? The development was held on this controlled environment chamber. Throughout the automation process, the different systems which make up a controlled environment chamber were adapted. Heating system, refrigeration system, humidification system, ventilation system, and finally lighting system, all of them to control the variables of temperature, relative humidity, and solar lighting, and likewise be able to simulate a desired environment inside the chamber. Then, what is CDIO initiative? CDIO put the student inside a scenario in which they work on the conception, design, implementation, and operation of real system and product. The initiative aims for promoting the development of a skill to identify, formulate, and solve engineering problems within the constraints that may arise. There are some of these skills which are very important, as the ability to work in multidisciplinary teams and understanding the worldwide engineering solution impact, economic, environmental, and social. What about concept stage? This is the flowchart representing the team that look over on the project, the stage development strategy CDIO. Sometimes, at any stage, the current status should be evaluated and the decision to go to an earlier stage or continue to the next should be taken. The concept stage is essential. Signs of subsequent development may be compromised by inadequate approach. Therefore, the role of leading teacher is determinative. Furthermore, one of the main conceiving stage activities to be carried out by the members team is the development of a good state-of-the-art of the problem. Design stage. It was established an action plan that allowed distribute tasks among members and be clear how to fulfill the automation requirements. At this stage, the experience of leaders and advisor teachers may propose development schemes with a higher probability of success. In the design stage, the students take into account the possibilities of using the expertise and guidance of teachers, and also they help each other to use the different skills that possibly each one has or were developed in different courses. This work was organized through top-down methodology, in which the idea is to have an overview of everything that must be done and then approach the project in stages. Everything is captured in a distribution diagram, reflecting development cycles. The control environment chamber is a real system that involves different variables at the same time. This was one of the biggest challenges. Now, implement stage. This stage is where most problems arose. So, the implement stages propose several challenges to all team members. This stage is characterized by the need to return to some aspect of the concept and design stages, to refer them if required, taking into account the lesson of learned during implementation. Sometimes it is needed to follow a forward backup pattern of development while implementing, as shown in this slide. Finally, also this stage required a long time. All expected objectives were achieved. All development described allowed the team to validate the importance of good planning, which asserted that the skill levels of the development group were strengthened while they giving solutions to problems.
The developed project allowed obtaining as a main result a functional controlled environment chamber for both academy and industry tests. All the knowledge gained during the electronic engineering career was applied as the students learned how to face an engineering project and satisfy the requirements that the client demands. This project focuses on the instrumentation, control design, signal conditioning, connection and electrical drawings, programming and communication protocols. This is the door frame where the fluorescent lamps are installed. The door frame has a lock to secure it to the controlled environment chamber. This is the lighting system. It consists of several fluorescent lamps of 3 different temperature colors. This is the resistive heating system, evaporator and fans, and the overtemperature emergency stop. Here's the humidity and temperature sensor, the sensor bulb of the thermostat, drainage system of the evaporator. These are walls with holes to homogenize the temperature of the controlled environment chamber. It has 2 trays, which can generate 2 levels in the enclosure. Below the tray, first level is the humidification heating system submerged in water, the level detector and automatic filling for that resistant is always underwater. This is the PLC of the controlled environment chamber. When the PLC is on, it shows the shield of the UPV, the name of the project, and the people who made it. It can be configured in a similar way as seen in PC control. The system can be controlled from a LabVIEW interface communicating with the PLC by Modbus protocol. The graphical interface developed in this software can monitor the resistive heating system, fans, compressor, polarization system, a humidification heating system, and the start time of the fluorescent lamps.
Beyond the mere technical solution, a main goal to achieve through this project was that the involving students develop competence in control area, beyond those enhanced by the electronic engineering program. Each student developed skills asynchronously. Each participant followed his own path, in which activities are sometimes collaborative and sometimes are competitive. The electronic engineering program of the Universidad Pontificia Bolivariana aims to strengthen the following competences in automatic control area: operate, choose, and design the installation of instruments for monitoring and control system. Other, for example, conceive, implement, design and operate conventional linear controller for process. Design experiments to model system from static, dynamic, or frequency response. Conceive, design and implement industrial automation project. Plan and evaluate condition of installation, operation and maintenance of electrical and electronic industrial. And finally, for example, conceive and design circuits for rectifying and regulating power using solid-state devices. Now, it's very important to establish an analysis of competences development. So, it's shown the average of appropriation of the competence among the student members of the project. This represents electronic engineering program profile, and this profile is compared with the skill in the student of the project before and after running the project. This shows that the development of the project improves almost every competence in control area. Finally, it's important to define some conclusion of the project. First, the experience of the student involved in the project control environment chamber was quite broad, since many challenges were present, but each one was solved. After completing the automation project can demonstrate the importance of each step of CDIO in the development of the system. Thus differentiating this stage, it helped make better implementation structures and helped make the execution of each step more carefully to not having to return to a previous stage or help return less frequently. The development group faced challenges that had to provide solutions based on the knowledge imparted during the courses. This solution helped strengthen the capabilities of each student to form in them competences that sometimes exceed the competences expected by the engineering school. Now, all development analysis was conducted to verify that the task at the School of Engineering and the Universidad Pontificia Bolivariana innovative teaching strengthened the skills to carry out the project. And finally, our last conclusion is that different laboratories have used the controlled environment chamber in several experiments, which show the interdisciplinary nature of the equipment, whose use is not restricted only to a determined area. Thanks for watching. Questions?